Welcome to Accelerated Engineering. My name is John, and this is the video encyclopedia entry for the permutation A function, which is the permutation function that allows for repeats. Of all the combinatorics functions, this is the one that will result in the largest numbers for the smallest values n and r, respectively. That's because calculating the number of permutations allowing for repeats results in a function n to the power of r. Let's look at an example of this. Let's say we have n is equal to 2. Well, what does that mean? Well, this is like counting in binary. For example, in binary, you can only have the values 0 and 1. R is 2, which means we pick 2. This is always going to be two-digit numbers. Because Excel is finicky with numbers, I'm just going to use A and B, and you can imagine that 1 and 0, but this will be the way that this goes. I could have A and A. That's one permutation. I could have A and B. That's another. B and A is another valid permutation of these letters. And my last one would be B and B. And that's it. That's all of my permutations. But I have AA and BB, which is repeated values. Remember, the permute function would not allow these as being valid solutions, if you will, because they have repetitions. The best way to think about this is like if you were rolling dice or flipping coins, but you really care about the order. In fact, let's redo that this way. If I was flipping coins, I could flip heads, 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 tails, tails, heads, or tails, tails. That's all fine and good. What if I did 3? Well, permutation A immediately spits out that there are 8 possible combinations, and I think that's intuitive at this point. That's very intuitive to me. I've flipped a lot of coins for no good reason. But I could get heads, 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 tails, heads, tails, heads, heads, tails, 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 heads, heads, tails, heads, tails, 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 heads, tails, tails, tails. Is that 8? Yes. Okay, I can still count. This is good. And you can see that that's going to explode relatively quickly. In fact, if I increase the number of things that I could pick from to 4, for example, you can imagine this as rolling a 4-sided dice. Or actually, let's roll a 6-sided dice, but only roll it twice, because that's still a manageable number. There's 36 combinations of rolling, there are 36 permutations of rolling a 6-sided die twice. You could roll a 1 and then a 1, a 1 and then a 2, a 1 and then a 3, blah, 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 blah. This goes on for 36 lines. I'm not going to type it all out. Lots of options. This is the one that explodes. So far as limits go, permutation A allows for a larger value picked than the value input, which is a useful thing to know. For example, if I flip a coin 7 times, this will give me the number of orders of flipped coins, heads and tails, that I could possibly get. And unless I miss my guess, it should be the case that this value will cap out at about the maximum value Excel can express, which is 1.7-ish times 10 to the 308th power. It's a ginormous number, astronomical. I think I've said it before, astronomer's wish. There we go. And there's a number error, which would be about the right timing. Limited functions to this include the permute, the combine, and the combine A function, which is the combination function that allows for repeats. But this is the grandpappy of them. There are more permutations allowing repeats than there are for any combination of n and r than there are for permutations, combinations, or combinations allowing repeats. I think that that's cool. This concludes the video encyclopedia entry for the permutation A function. Please take a moment to like, subscribe, drop me a comment, and thanks again for watching.